Did you know that a year on Pluto lasts for 248 Earth years? That's right, one full orbit around the Sun takes 248 Earth years. This is due to the fact that Pluto lies in the far reaches of our solar system, making the distance it needs to travel around the Sun much greater than that of our own planet. The sheer size of this journey makes each Pluto year incredibly long. Now, imagine celebrating your birthday every 248 years. That's a long wait for a birthday cake, isn't it? Pluto, the farthest celestial body, was discovered by Clyde Tombaugh in 1930. Let's take a step back into the early 20th century. The year is 1930. The world is in the throes of the Great Depression, but up in the stars, a new discovery brings a glimmer of excitement. A young self-taught astronomer named Clyde Tombaugh, working diligently at the Lowell Observatory in Arizona, stumbles upon a tiny distant speck moving across photographic plates. He's discovered a new planet, the 9th in our solar system, a remarkable achievement that propels him into the annals of astronomical history. The discovery of Pluto was a significant milestone, not just for Tombaugh, but for the entire scientific community. It sparked a wave of enthusiasm among astronomers and the public alike. Here was a celestial body, far out in the mysterious, uncharted frontier of our solar system. It was named Pluto, after the Roman god of the underworld, a fitting name for such a distant and mysterious object. For a while, Pluto enjoyed its status as the 9th planet in our solar system, the farthest outpost on the frontier of our astronomical knowledge. It symbolized the human spirit of exploration and discovery, our relentless curiosity to understand the universe and our place within it. But the excitement about the new planet was soon to be replaced with a heated debate. In 2006, the International Astronomical Union, IAU, decided to demote Pluto from a planet to a dwarf planet. This decision led to a heated debate and a schism in the scientific community, sparking a controversy that still rages on today. So, what led to this decision? The IAU, the official body responsible for classifying celestial bodies, set out 3 criteria that a celestial body must meet to be considered a planet. First, it must orbit the Sun. Second, it must be spherical, or nearly so. And third, it must have cleared its orbit of other debris. Pluto, along with its moon Charon, ticks the first 2 boxes. It orbits the Sun and is spherical in shape. The issue arises with the third criterion. Pluto's orbit is located in the Kuiper belt, a ring of bodies beyond Neptune. This is a region littered with icy objects left over from the formation of the solar system. Because of this, Pluto hasn't been able to clear its orbit of other debris, thus failing the third criterion. This classification of Pluto as a dwarf planet was not met without opposition. Many argued that the definition was flawed. They pointed out that even Earth, Mars, Jupiter, and Neptune haven't completely cleared their orbits either. So why single out Pluto? Others suggested that the criterion was too vague and needed further clarification. Moreover, the decision seemed to disregard the historical and cultural significance of Pluto. After all, generations of students had learned about the 9 planets of the solar system, and Pluto had always been part of that club. To suddenly demote it felt, to many, like an affront to tradition and an upheaval of our understanding of the solar system. So, it seems Pluto was stripped of its planet status due to its inability to clear its orbit. But not everyone agreed with this decision. The debate over Pluto's classification, it seems, is far from over. The decision of the IAU sparked a controversy among the scientific community and the general public. It's no secret that this decision did not sit well with everyone. The backlash was swift and fierce, coming from both the scientific community and the public. Many felt the IAU's decision was hasty, not taking into consideration the emotions and sentiments of those who had grown up knowing Pluto as the 9th planet. Let's talk about the scientific community first. A number of prominent scientists, astronomers, and researchers argued against the IAU's definition of a planet. They pointed out that the definition was not only vague, but also failed to capture the diversity and complexity of celestial bodies in our universe. They argued that Pluto, with its 5 moons, complex atmosphere, and geologically active surface, had every right to be classified as a planet. Then there was the public backlash. Pluto, the tiny icy underdog at the edge of our solar system, had won the hearts of people worldwide. School children were taught rhymes and mnemonics to remember the names of the 9 planets. Pluto, being stripped off its planetary status, felt like an erasure of childhood memories. There were petitions, social media campaigns, even protest marches, all aimed at restoring Pluto's planetary status. There were arguments made in favor of keeping Pluto as a planet too. Some suggested that the IAU's decision was Eurocentric, ignoring the perspectives of other cultures where Pluto is still considered a planet. Others argued that the decision was based on a narrow and outdated understanding of what constitutes a planet. The most compelling argument, perhaps, was that the decision to demote Pluto was more about semantics than science. It was a labeling issue, not a factual one. After all, whether we call it a planet or not, Pluto remains the same fascinating celestial body it always has been. Despite the controversy, the IAU's decision still stands, but the debate is far from over. The passionate response to Pluto's demotion is a testament to the enduring fascination we humans have with the cosmos. It's a reminder that our understanding of the universe is always evolving, always open to debate, and who knows, maybe one day Pluto might regain its planetary status. Only time will tell. Even today, the debate about Pluto's status continues. The question of whether Pluto is a planet or not is far from settled. It's like a cosmic game of ping pong, with scientific opinions bouncing back and forth. On one side of the net, we have those who argue that Pluto, despite its small size and eccentric orbit, should be classified as a planet. They point out that Pluto has 5 moons, a multi-layered atmosphere, and even an ocean beneath its icy surface. These are all features typically associated with planets. On the other hand, we have those who maintain that Pluto, being smaller than our moon and located in the Kuiper Belt, a region of the solar system beyond the orbit of Neptune, filled with small icy bodies, should be categorized as a dwarf planet. But here's where it gets interesting. New research has surfaced that supports the idea of Pluto being a planet. Some scientists argue that the definition of a planet should not be based on its location or what's around it, but rather on its intrinsic physical properties. They propose a geophysical definition of a planet, one that includes any celestial body that is large enough for its gravity to shape it into a round form, but not so large that it initiates nuclear fusion like a star. If this definition is accepted, not only would Pluto regain its planet status, but so would many other celestial bodies in our solar system. This ongoing debate about Pluto isn't just about semantics. It's about how we classify and understand the vast universe that surrounds us. It challenges us to refine our definitions and to question our assumptions. It pushes us to explore more, to learn more, and to see the universe not just as it is, but as it could be. Whether Pluto is a planet or not, this debate has surely made us question and explore more about our solar system. Regardless of its status, Pluto holds an important place in our solar system. Let's delve into the significance of this celestial body, dwarf planet or not. To understand Pluto's importance, we need to appreciate its unique attributes. This little world, situated in the Kuiper Belt, a region populated by icy bodies and remnants from the solar system's formation, is a time capsule from a bygone era. Pluto's surface is a complex and varied landscape with an exotic mixture of nitrogen, methane, and carbon monoxide ices. It has mountains as high as those in the Rockies and a heart-shaped glacier that's the size of Texas and Oklahoma combined. This glacier, named Tombaugh Regio, is one of the solar system's most prominent features and is composed of nitrogen ice. But what makes Pluto truly significant is the scientific research and understanding it has sparked. The New Horizons mission, launched in 2006 by NASA, had the primary goal of performing a flyby study of the Pluto system. In mid-July of 2015, after a journey of more than 9 years, New Horizons made its closest approach to Pluto, providing an unprecedented up-close view and gathering a wealth of data on Pluto's geology, surface composition, temperature, and atmosphere. These findings have led to groundbreaking insights into this distant world. For instance, we now know that Pluto is geologically active, with a subsurface ocean that could potentially harbor life. The mission has also given us a better understanding of the Kuiper Belt and the early solar system. So you see, the importance of Pluto goes beyond the semantics of its planetary status. It's a key to understanding the history and diversity of our solar system, a fascinating world that continues to surprise and enlighten us. Whether a planet or a dwarf planet, Pluto remains a fascinating and significant part of our cosmic neighborhood.